Hello everyone, in this video we're going to explore the topic 2.2 change in linear functions and exponential functions of the AP Precalculus. Alright, first we're going to explore the formulas on the left hand side right here. Alright, we're going to talk about the similarities and differences of the arithmetic sequence and linear functions. Alright, so in the last topic we learned the formula for the arithmetic sequence given the initial value. So a sub n equal a sub 0 plus d times n. D is a common difference. A sub n is the n term. A sub 0 is the initial values. And you look at this formula right here, you see that this formula is similar to the linear function in slope-intercept form, which is f of s equal to b plus a s, where a is the slope and b is the y-intercept. And the linear function in point-slope form you learn in Algebra 1, which is f of s equals to yi plus m times s minus si, where si and yi is the points and m is going to be slope. Now the formula for arithmetic sequence is going to be similar. Alright, so it could be a sub n equal to a sub k d times n minus k, where a sub k is the k term, a sub n is the n term, and d is going to be common difference. Alright, now we're going to move on to the second one. We're going to talk about the geometric sequence and exponential functions. Given the initial value, we're going to use this formula g sub n equal g sub 0 times r raised to the power of n, where g sub n is going to be n term, g sub 0 is going to be initial value, and r right here is going to be common ratio. Alright, exponential function is going to be a times b raised to the power of s. Now keep in mind, you need to write f of s equal to a times parenthesis b raised to the power of s, only b raised to the power of s, not a. Okay, so a right here is called the initial value or the y-intercept. Now, if you're given 2 points, so you're going to use this formula right here. G sub n is going to be g sub k raised to the power of n minus k. Alright, g sub k is going to be k term. G sub n is going to be n terms. Alright, r right here is going to be common ratio. Alright, similarly, we're going to use this one for exponential function. Alright, now the last one, we're going to explore the differences between the linear functions and exponential functions. The linear function is given by the formula f of s equal to b plus a times s, where a is the rate of change or the slope of the linear function. B right here is the y-intercept or initial value. Now in the exponential function, f of s equal to a times r power of s, where a is the initial value or the y-intercept, r is the common ratio. Alright, so over equal length input value intervals, the output values change at a constant rate, and that is the linear function. While in exponential function, over equal length input value intervals, the output values change proportionately. Right? So let's take a look at the example right here. So given the table where s goes from 1 to 5, and f of s goes from 3 to 11, f of s increasing by 2 units. Alright. So, because over equivalent input values intervals right here, the output values change at a constant rate. You see that the constant rate is 2. So this is a linear function. So you need to explain like this. Now let's take a look at the second example. Alright, given a table where x goes from 1 to 5 and f of x goes from -1 to 9. So we need to find the change in f of x right here. Increasing by 1 unit. This guy increasing by 2 units. This guy increasing by 3 units. And this guy increasing by 4 units. Alright, so this guy right here are not constant, right? So this is not a linear function. Now let's take a look at the second example right here. So in order to get 8 from 4, we're going to multiply by 2. Right, to get 16 from 8, we're going to multiply by 2. To get 32 from 16, we're going to multiply by 2. And to get 64 from 32, we're going to multiply by 2. And every single time, we're going to multiply the output by 2 to get the next output. So over equivalent input values intervals, the output values change proportionately, right? So we need to explain like this right here. And this is exponential function. Now let's take a look at the next example. To get 4 from 3, we're going to add 1. To get 6 from 4, we're going to add 2. To get 9 from 6, we're going to add 3. And to get 13 from 9, we're going to add 4. Alright. So we see that this guy right here is not a constant. Right? So it's not a linear function. And then this guy right here, there is no common ratio. This is not an exponential function either. Right? So this table does not represent a linear function or an exponential function. Now let's move on to the next example. A large theater has rows of 6 where the number of 6 in each row can be modeled by an arithmetic sequence. So the problem already lets us know that we need to use the arithmetic sequence, which is the one on the left hand side right here. Alright, if the fifth row has 31 6, so we have the first order pair 5, 31. Now, and the 11 rows has 49 6. Alright, so we have the second one. It's going to be 11, 49. Alright, now question. Determine how many 6 there are in the 25th row. Okay, so we have 25 right here. And then this guy equals to how much? Alright, this is what we need to find. Alright, we're going to use the formula right here. So we have a sub n equal to a sub k plus d times n minus k. Now we need to define a sub n. So a sub n is the number of 6 in n row, right? Now if you use this formula, keep in mind the bigger values is n and the smaller values is k. The bigger values right here is a sub n. The smaller values is a sub k. So we have a sub 11 equal to a sub 5 plus common difference, right? 11 minus 5. Now a sub 11 is going to be 49. I substitute over here. 49 equal to a sub 5, which is 31 plus common difference 11 minus 5. Alright, so I'm going to subtract 31 both sides, so it could be 18 equal to d right here. 11 minus 5 is going to be 6. I'm going to solve for d. So d equal to 3. So I already have the common difference is 3. Alright, so I'm going to use this formula right here to find the a sub 25. Alright, so I use this formula one more time. So it could be a sub 25 equal to a sub k plus the common difference is going to be 3. So I put 3 right here, parenthesis 25 minus k, right? Now, for k and a sub k right here, I'm gonna pick any of this guy right here, alright? If you pick k is 11 and then a sub k must be 49. If you pick k is 5 and a sub k must be 31. So it doesn't matter what number you're gonna use, you still get the same answer. Alright, so I have a sub 25 equal to a sub k. So I'm gonna pick 49 right here. So it's gonna be 49 plus 3 times 25 subtract k, which is 11. Alright, so I have 49 plus 3, 25 minus 11 is going to be 14. Alright, 3 times 14 is going to be 42. 42 plus 49 is going to be 91. Now, what if I pick this order pair? Alright, so I'm going to substitute over here. So I have a 25 equal to AK, which is 31. So it can be 31 plus 3 times 25 minus k, which is 5. Alright, so it can be 31 plus 3 times 25 minus 5, it can be 20. Alright, so it's going to be 31 plus 3 times 20, it's going to be 60. So 31 plus 60, it could be 91. So, as you see that, it doesn't matter what order pair you're going to pick as AK, you still get the same answer. Now let's move on to the last example. Immediately following the AP Precalculus exam, memes are created and shared online. The number of people that seen the meme can be modeled using a geometric sequence, where 1 hour after the exam ends is hour 1. After hour 3, a total of 2,500 people has seen the meme, and 25,000 people has seen the meme by hour 6. Using this model, how many people will have seen the meme by hour 10? Alright, first we need to define the variable. So we're gonna let g sub n be the number of people seen the meme by hour n. Alright, now we're gonna use the formula on the left hand side, which is g sub n equal to g sub k times r raised to the n minus k, because the question gives us the hint that we need to use the geometric sequence to model this problem. Alright, so we have g sub n equal to g sub k times common ratio n minus k. Alright, so at hour 3 we have 2,500 people. Alright, so we have 3 comma 2,500. And the next one we have by hour 6 we have 20,000 people, right? So it could be 6 comma 20,000. Now the question asks us to find the number of people by hour 10. Alright, so we have hour 10 right here and the number of people right here, which is question mark. Alright, so look at this one, right? So 6 right here bigger than 3. So we label this guy as k. This is g sub k. Now this is s n and this is g sub n. Alright, so we have g sub 6 equal to g sub 3 times common ratio power of 6 minus 3 and minus k. 6 minus 3. Alright, so g sub 6 is going to be 20,000. So we have 20,000 here equal to g sub 3, which is 2,500 times common ratio 6 minus 3, which is 3. Alright, we need to divide both sides by 2,500. Alright, so this guy must be 8 equal to r power of 3. So h, which is 2 power 3. Alright, so r equal to 2. And the common ratio equal to 2. Now we substitute this guy back to this formula right here. So we have the general formula g sub n equal to g sub k times common ratio, which is 2 power of n minus k. Alright, now in order to find the number of people by our 10 right here, so this is my new n, right? And this is my new g sub n, right? So in order to find this one, we need to consider this guy right here or this guy right here as g sub k, right? This guy no longer g sub n, right? This guy must be g sub k. So you can pick any other pairs right here, right? You still get the same answer, right? As I did in the last example, right? So now I have g sub 10 equal to g sub k. So I'm gonna pick this guy right here, alright? This guy as g sub k. So g sub k is my right here should be 20,000. So I have 20,000 times common ratio n, which is 10, minus k, which is 6. Alright, so I substitute. So I'm going to simplify this one. So it can be 20,000 times 2. 10 minus 6, which is 4. Alright, so it can be 20,000 times 2 power of 4. It's going to be 16. And multiplied by this one, it's going to be 320,000 people. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.